Okay, this is Chapter 9, Acids, Bases, and Salts, Lesson 6, and we're going to talk about neutralization reactions today. What is neutralization? Neutral means neither acidic nor basic. It means that our hydrogen ion concentration is equal to our hydroxide ion concentration. Neutralization occurs when an Arrhenius acid and an Arrhenius base react to form water and a salt. Antacid for upset stomach neutralizes the acid in the stomach and makes it neutral, and it provides a salt for relief. The general reaction for neutralization reactions are acid plus base yields salt plus water. And we've been working on these already for the last couple of days, so this should be really easy and almost a review. The H plus from the acid and the OH minus from the base combine to form water. The Cl minus from the acid and the Na plus from the base in this example combine to form a salt. Neutralization reactions are always double replacement reactions. Remember, just like any compound, the positive and negative charges must be balanced. Use the crisscross rule, drop and cross, to figure out the correct formula for the salt. Water, of course, is always H2O. The net ionic equation for neutralization reactions after spectator ions are crossed out is simply H plus OH minus yields H2O. This is really important. Sometimes the regents will ask, what is the net ionic equation for neutralization? It is simply the formation of water. Let's take a look at a couple of these examples. H is plus 1, Br is minus 1, K is plus 1, OH is minus 1. So my plus is going to go with my negative to form water, and my plus is going to go with my negative to form a salt. So KBr. This is plus 1 minus 1, so I don't have to do any other work in this problem. In my next one, Na is plus, OH is minus, H is plus, acetate is minus. So my plus goes with my minus to form water, and my plus, my Na, goes with my minus to form a salt. NaC2H3O2 is sodium acetate. In the next one, my plus goes with my minus, my plus. Now here, PO4 has a minus 3 charge. This is going to give us some problems when we go to balance. So let's do the easy part first. H and OH makes water. Remember, I don't bring the 3 with me. The 3 by the H is only there because it combined with phosphate. This is simply H2O. Then my K and my PO4 are going to hook up. My K has a plus 1 charge. My PO4 has a minus 3 charge. Therefore, I have to bring this 3 down here, and I wind up with K3PO4. Now this I have to balance. I have 3 Ks on the right, therefore I need 3 Ks on the left. That's going to give me 3 H's right here, plus the other 3 H's here, for a total of 6 H's, which means I need to put a 3 here as well, because 3 times 2 is 6. And then I've got 3 oxygens here, and that's taken care of over here with the 3 KOH. In the last example, H is plus 1, NO3 is minus 1, Ca is plus 2, OH is minus 1. My positive hooks up with my negative, so I'm going to make HOH, which is my H2O. Remember, I don't bring any of the subscripts. The subscripts are there because of what it combined with on the reactant side. And my Ca is going to hook up with my NO3, but my Ca's got a +2 charge, and my NO3 has a -1 charge, which means when I drop and cross, this goes in parentheses, and I have Ca NO3 2. Now I have to balance. I have 2 NO3s, which I have over here, 2 NO3s. I have 1 Ca, that's good. And I have a total of 2 H's here. I have 2 H's on the left, and I have 2 H's on the right, as a total of 4 H's, so I need a 2 here. So that's 4 H's, and then I have 2 O's here, and I have 2 O's here in the CaOH2. Okay, let's just review. We don't always get a neutral solution. If I have a strong acid and a strong base, my product will be neutral with a pH of 7. However, if I have a strong acid and a weak base, I will have a slightly acidic solution when I am done, because I have a strong acid and not a strong base, and my pH will be less than 7. If I have a weak acid and a strong base, that means my ending solution will be slightly basic, and my pH will be greater than 7. Okay, that's it. We have one lesson left in this unit.